My name is Nicholas Piccini. I'm a senior and I completed the Image Quilting by Texture Synthesis project.
Okay, so in this problem, the goal is to create a larger texture that is as seamless as possible from a given sample image. The pictures on the right are taken from the Image Quilting for Texture synthesis paper and are some examples of what we're trying to make. You can hardly tell that the larger images are really just made up of small patches from the sample image. So I'll walk you through the algorithm used for this in 3 steps and then show you some of my own results. The first step was to create a texture made up of random square patches taken from the sample image. The size of these patches is set by the user. I use patches that were about 1/5 the size of the sample image. The algorithm itself is pretty simple for this. You just get a random XY coordinate on the sample image, grab your patch, and then add it to the output texture in a left to right, top to bottom order. As you can see, the result isn't very good. The outlines of the patches are obviously very noticeable. And because of this first step was mainly so that we could have something to compare our later results to. In the second step, we look for patches that have similar overlapping border regions. The size of the overlap region is set by the user. I use an overlap of about 10 to 20% of the patch, depending on the image. The hope is that if two patches have similar overlaps, then the outlines between them won't be as noticeable. How similar two overlapping regions are is determined by calculating the sum of squared differences, which is done by subtracting each pixel in the region from one another, and then squaring them, and then adding them all together. If we find a patch that meets a certain threshold of similarity, we'll hang onto that patch, and then at the end, randomly select one of the patches to be added to the output texture. This creates a better result than the purely random one, but the outlines of the patches can still be seen. Some additional notes about some specific things that I did at this point of the algorithm. When I was searching for good patches in the sample image, I scanned left to right and top to bottom in increments of half the overlap size. Every time I started out at a random XY coordinate so that the same patches wouldn't keep coming up. I set the max number of patches that I wanted to save to 5, and then if that number was hit, I broke out of the search to save some time. After that, one of the 5 was picked randomly to be added to the image. If no matches were found, then I restarted the search with twice the original tolerance, and that way the algorithm wouldn't stall out or black patches wouldn't be added to the texture. The final step was to cut the overlapping regions along a path of minimum error. The cost image is in the figure to the right, and it's essentially the matrix obtained while calculating the SSD before you sum all the values together. The green line down the middle, that's basically the path of least resistance, and it's where the overlapping regions are the most similar. Anything to the right of the line will be kept in the new patch, which is the picture on the left of the figure, and anything to the left of that line will be kept by the overlapping patch that's already present. Here are the results for all 3 methods together using an image taken from the paper. The final result is definitely the cleanest, and I think it's pretty hard to tell where the borders of the patches are. And here are some of the results from pictures that I took from textures that I found around campus. So in conclusion, the strengths of this project was that it does create some realistic looking, almost seamless textures from a sample image. A weakness is that it can take kind of a long time if you want a large output texture. Alignment was a challenge. I got lots of like off by one errors throughout this project, but it was really enjoyable seeing everything come together in the final results.